Hey, welcome to Adaptive Computing. I'm Sean.
Welcome, don't be shy, come have a seat.
Come on in, have a seat. We're going to talk about Moab, HPC, and the Cube. The Cube, C-U-B-E Cube.
This is the All-Spark Cube. Come see a demonstration.
Don't look at it. Don't look. You looked. Don't look. Once you look, you can't look away. That's the problem. So, welcome to Adaptive Computing. We're going to talk just a brief bit about Moab, HPC, and give a demo using the All-Spark Cube. Why the All-Spark Cube anyway, Ian?
We named it the All-Spark Cube after the 2007 Michael Bay film called Transformers. All-Spark is the life-giving device that gives ordinary electronics and mechanical devices life.
So if I put my cell phone up there, it'll like come to life, right? Turn into a... Do it. It's not working.
Hello? Can you hear me now?
It's not working. It's not that kind of an All-Spark Cube. Our All-Spark Cube is to demonstrate Moab's optimization and scheduling parameter. Do we have that up? Yeah, we do. So Moab is currently running jobs in our cube.
All right, I will cue the jobs for you, Sean.
Cue it up. There you go.
There it goes.
So this cube has 4,096 three-color LEDs. Right about there, right? Close enough. We're emulating. Each light emulates a core, and 4 cores make up a compute node. So that's how it's constructed. Every one of those lights is wired. It's wired, right? By hand. Someone soldered those and programmed this whole thing to run. So, by adaptive computing people and the family members of adaptive computing.
That's right, and Sean, the cube actually represents 512 servers. Moab is currently scheduling jobs to our simulated cluster, which is being represented here by the lights. Each of the different colors represents a different job. Each LED represents a processing core, and a group of 8, since most of these are 8 cores, is 1 server. So pretty quick, as this thing populates, we'll get up to about 98 to 99% utilization, which is very important.
That sounds like it's an optimization topic. Is optimization important?
That's a great segue. I don't think optimization is very important.
Nah, no one cares about optimization in clusters. Who cares about that, right?
Why don't we care, Sean?
Because we all live in a matrix. We all live in a matrix.
Right?
Matrix. Are you looking at the matrix?
Do you see the woman in the red dress, Sean?
Yes, no, I don't see her. Don't look, in fact.
I do, so I'm just going to leave it up for a little while.
Don't look. No, optimization really is important. You spend all this money on a cluster, you want it to perform well, right? After all, you want to be super in your supercomputer, right?
That's correct.
You want to buy one of those? Okay.
Hang on, let me check on the price. Hang on. $50,000.
I have $50,000. $60,000. Sold. $60,000. That's a
and a free T-shirt. Get the man a free T-shirt.
Thank you for buying. Come back tomorrow. The cube will be gone. Anyway, we're going to populate the Moab with jobs. Let's talk about why Moab is so good at scheduling. Moab allows for maximum utilization of a supercomputer by mastering scheduling, employing fair share, power management, auto-responding to failures, job arrays, and most importantly, policy-based optimization. That's what Moab's all about. Policy-based optimization.
That's the policy-based optimization move.
That's it. Policy-based optimization.
That's right.
That's scary.
Now, Sean, there's one question I have. See, I feel especially important, and I feel like my job should go to the front of the queue.
Okay. That's because your mom said you were important.
She said I was special. That is correct.
And you believed her. So for special people, for important folks, using technologies like, or using concepts like fair share, we can have your job kind of inch its way in front of everybody else's. Sure. We do it by reprioritization. So defining who you are and reprioritizing your job, Moab either adjusts your priority either higher or lower, trying to meet your fair share target. that's fair share. Just one of the mechanisms where we can achieve up to
98 to 99%
utilization rate. Now, if we were just a simple first in, first out scheduling system, we'd probably get how much?
Maybe 70 to 80.
80%. But we get, don't you have an example of someone who deployed this?
I do. We had Cyfronet, the largest supercomputer in Poland.
All of Poland.
In the entire country, the entire region of Polish lands.
Yeah, the whole Poland.
Poland.
Yeah, all of Poland.
The
largest supercomputer.
So they were using Maui, which is also an adaptive computing product, but open source.
Yep.
And they were getting about 60% utilization.
Not
They
bad.
upgraded to Moab.
Not bad.
They achieved at least 90% utilization, and they peak at about 97% utilization.
Sweet. That's a high utilization rate.
Super high utilization.
Super high utilization.
Double arm utilization maneuver.
Hey, but Ian, how about scalability? Does Moab scale?
Apparently it does, Sean.
It does scale, and not the kind that you get off of fish either. But thanks for here all week. Come on, Deb, that was funny. All right, we scale up to million-plus jobs we can handle, hundreds of thousands of cores, tens of thousands of compute nodes, all being utilized by thousands of individual users like you, submitting jobs, just like us, just normal people.
Absolutely.
In fact, did you know that we are the largest used workload management software in the world? Not just in Poland, but the whole world.
Not just the Polish region,
but the whole
entire globe.
It says so on one of our marketing documents, so it's got to be true, because I read it on the internet.
It's absolutely true.
And it's true on the internet.
Everything you read on the internet is true, Sean.
That's what I heard.
Yes.
Hey, how about job submission?
Let's do it.
Ordinarily, when you submit a whole bunch of jobs, performance goes down. Not with Moab. Look at that.
So basically what you're saying, Sean, is Moab is really good at Tetris.
Moab is infinitely good in Tetris because it's running in 10 dimensions. Moab not only shapes and looks at the job. Are all compute jobs the same dimension, same time, same number of cores?
Are they all the same? Jobs are all the same size, same type of workload, right?
Sure.
They're homogeneous. They all taste like chicken. I love it. No beef, no pork products of any kind.
What color is the sky in your world? That's not true, because all jobs come in different shapes and sizes, right? So Moab is constantly evaluating the shape of the job, how much time it's in, how much time to go, and makes up to 98% utilization.
That is
correct.
correct.
We do that by playing Tetris.
Moab cheats at Tetris. There you go.
How about job arrays? Did you know that we can submit up to 100,000 jobs with one single job?
Gotta have a really big head node.
Got to have a pretty big head node. No, that's right. I have a big head.
That you do, Sean.
That's not what he was talking about, though. Oh, okay. How about is Moab GPU aware?
Absolutely. I believe that sign right there says so.
It says right there, optimized scheduling of Intel Xeon Phi, and it says so it's true. But not only my technology from Intel, but also around the corner, NVIDIA, right?
That's correct. This demo to the left side schedules NVIDIA Tesla cores that are clear across the show floor at HP's booth. And so in HP's server, all the visualization you see there is run from NVIDIA Tesla GPUs, and the machine that actually runs these three monitors is not beefy at all. It's actually quite small.
Normal.
Yeah,
Just a normal
so it's running off of advanced hardware over in HP's booth.
Way over there.
Yeah.
And it's being displayed over here. Very fast, I might add. We have a GPU demo, don't we? Yeah.
Yes, we do. We have the Intel Xeon Phi demo.
That's right.
Oh, and we have a visualization.
That's what I was saying.
Aha.
That's what I was trying to say. I didn't say it very good.
I believe that's it.
Look at that. Ooh. Try not to look at that. Try not.
That's correct.
You can't do it.
We're not responsible for any seizures that may happen in front of the cube area. So
It's so
stand
beautiful.
back.
It's so beautiful. All right, so we all know that system administrator's job is to run around and put out fires. We know that, right? Put out fires.
Going? Fire
Does
simulation?
that mean that
go.
we all want to be firefighters? No. We don't look at that. There it is. We're running around putting out fires. No, uptime automation. Right? Moab prevents workload failures by only placing workload on the appropriate nodes. Those nodes that are not healthy, we ignore. Another reason we can achieve up to 98% utilization. 98% utilization.
98% utilization maneuver.
That's right. Don't forget that. In fact, even if the node fails, we can reload the OS on it. How about auto SLA enforcement?
We can do that. And how do we do auto SLA enforcement?
You know, this is one of the features of Moab that really makes people angry. It's called preemption. So it's the one way not to make friends and influence people, but to guarantee service level agreements, we can preempt jobs that are currently running. We can suspend them, we can checkpoint them, we can, if you really want to make people mad, cancel them, make their job restart. But we do that to maintain service level agreements. That's because your mom says you're special and we can make your jobs run.
And that's correct. And a good friend of mine, to segue into a charging billing model, a good friend of mine, Chad Harrington, once said, what happens when you allow too much access to the cookie jar, open access, right?
Exactly.
Somebody eats a lot of cookies, maybe a lot of cookies they don't need. If you have a billing model for your cookies, they take what they need or what they have money for. And the same thing works for an HPC system to avoid wasteful utilization, to avoid overuse. A charging billing model can really help keep those things in check, which is available in our HPC Suite Enterprise Edition.
It's called Moab Accounting Manager. You may know it as Gold, but it's Moab Accounting Manager. Good idea. How about power management? You know, by being able to consolidate workload and maximizing idle nodes, we can get the best performance out of idle nodes and per the watt factor. So what nodes aren't being used, we can put them into some kind of power saving mode. Turn them off, suspend them, hibernate them, whatever you want. Moab is also grid and cloud management ready. So if we want to share between departmental clusters, all we do is set up Moab in a grid computing style, right?
That's correct.
That kind of forces departments to talk to one another, which a lot of people don't like to do anyway, but we can make you do that.
When it comes to grid and cloud, there's good clouds and there's bad clouds. I would wager this is a bad cloud, correct? You're getting rained on, lightning. There's good and bad ways to implement cloud. Now I'll move to our happy, fun, good cloud animation.
Happy cloud. Think happy thoughts.
Happy cloud. White billowy clouds moving through 16 by 16 pixels in very low resolution in 3D. Yes, happy clouds. So Moab is cloud for HPC ready.
Lovely.
And so Moab can provision both bare metal nodes, can provision obviously from hypervisors, can provision VMs as well, and create clusters of machines to have workload be put through there. So
that's right. So our All-Spark Cube being powered by Moab, real time. To conclude, we are Adaptive Computing, adaptivecomputing.com on the website. You also find us in social media, YouTube, Facebook, Checkbook, YouTube. No one got that, but you can find